Okay, so in continuation to the first law of motion, right, we have seen like what is inertia and the different types of inertia, right? Like inertia of rest, inertia of motion, and inertia of direction, right? So what was inertia? Inertia is the natural tendency of an object to resist a change in its position or in its state, whether it is the state of motion or it is the state of rest, right? So that is inertia. Now, what is momentum and what is the meaning of it, right? Okay. So basically, momentum measures the quantity of motion possessed by a body. Okay, right? And it is defined as, please write down, it is defined as the product of mass and velocity. Product of mass and velocity of the body. Right? So whenever there is a body which is moving, it is having some momentum. Right? Besides magnitude, momentum also has a direction. Okay. So at any instant, its direction is as the same as the direction of the velocity. Right? Okay. Because velocity is a vector quantity. So what will be the direction of the velocity will be the direction of the momentum. Getting that? Okay. So if there is a body of mass m, right, moves with a velocity v, then momentum, which is denoted by p, will be given as m into v, right? Where m is the mass of the body and v is the velocity with which the body is moving, right? M is the mass of the body. V, velocity. Okay. So it is denoted by p. P is m into v, right? Now what is the SI unit? SI unit of momentum is kg meter per second. Mass is in kgs and velocity is in meter per second. Therefore, unit is kg meter per second. Getting it? So, have you ever seen that whenever you are moving on some expressways or some highways, right? There is a speed limit for the vehicles. Have you noticed that? Like for car, the speed limit may be 100 kilometer per hour, and for bus or truck, it is 60 or 70 kilometers only, right? Do you know what is the reason behind?
Ma'am, can you repeat? Hello.
Can you hear me? I was on mute. So what is the reason behind? The reason is that the heavy vehicles, when they are moving with a small velocity even, they have a big momentum. They have a large momentum. Their P will be high because their mass is high. Their mass is more, right? In comparison to the car, right? So a car moving with 10 meter per second and a truck moving with the 10 meter per second will have different momentum, right? So truck will be having greater momentum in comparison to the car because of its weight, right? And that's the reason there is a speed limit on the highways for the heavy vehicles, and especially within the city, right? Their speed limit is like 30 or 40 kilometer per hour. Why? Because they have a big momentum, right? So if they hit somebody, if they hit some other, other moving body, they can create a big impact because of its momentum, right? So when there is a heavy mass, right, the momentum will be more. So this momentum is directly proportional to the mass of the body as well as the velocity of the body, right? So momentum is directly proportional to mass and it is directly proportional to velocity. Means if suppose a mass is small but its velocity is very, very high, even then it can create a big impact. And there's a reason why a bullet which is fired from the gun having very small mass of in grams can kill the person, right? Why? Because it is moving with very high velocity. And that's the reason it have a very high momentum and which can create a big impact. Okay, so whether vehicle is smaller, right? It is having small mass, but it is moving with a high velocity. Even then, it can create a big impact. Okay, it can harm the somebody, right? And there's a reason a bullet which is fired from the gun can kill a person. However, its mass is very, very small in grams, right? And similarly, when a truck having a big mass but moving with a small velocity of maybe 10 kilometer per hour or 20 kilometer per hour, and when it hits some other object moving on the road, can create a big impact. Is that clear? So one thing you need to note that momentum will be there only for the bodies which are moving. If the body is at rest, what will be its momentum? Can you tell me? If the body is at rest, what will be the momentum?
Zero.
Zero, because velocity is zero, right? So if v is zero, right, momentum will be zero. Okay, so momentum is there for the moving bodies only, right? So this come into the play when the body is moving, right? And now it depends what is the mass of the body and what is the velocity of the body. If mass is same, velocity is increased, then also it can create a big impact. If if velocity is same and mass is increased, then also it can create a big impact. Okay, so now suppose we have a question.
I got
So very first, write down what is given to you. So in this numerical, it is given like mass is 1000 kg and velocity is 72 kilometer per hour, right? Okay. Now look at this. P is equal to m into v, where m is in mass in kgs and v is velocity in meter per second. So remember, when you are writing, when you are doing some question, some numerical within physics, it is important to note what are the units, right? What are their standard units for the formula? If your physical quantities are not in those units, you will get the wrong answer. Your numerical will be totally wrong. You will get zero for that. Okay. So before putting the values within the formula, you have to first check whether they are in their SI units or not. So SI unit of velocity is meter per second, but it is given here in kilometer per hour, right? So you have to first convert this kilometer per hour into meter per second, right? So kilometer into meter. So 72 into 1 kilometer is 1000 meters. So you have to multiply with 1000, okay, upon hours, right? So 1 hour is equal to how many seconds? 60 into 60, right? So now this is in meter per second. Getting that? So now this is the velocity, okay? You can now put the values within the formula. So P is equal to M into V, right? This is the momentum. Now this is 1000 into V. V is 72 into 1000. upon 60 into 60 kg meter per second. Yes, now solve this. This is 36. 36 2 times is 72. So it is 1000 into 20, right? That is 20,000 kilogram meter per second. So what is the momentum of the car moving with the velocity of 72 kilometer per hour and having mass 1000 kg? It is 20,000 kg meter per second. So this is the momentum that car will generate, that car will produce by its mass and the velocity. Is that clear? So this is the answer. Yes, sir. Now let's see what is Newton's second law of motion. The second law of motion of given by the Newton states that the rate of change of momentum of an object is directly proportional to the applied external force and takes place in the direction in which external force is acting. Getting that? Okay. So what is Newton's second law of motion? Write down. Okay. That is, it states that the second law of motion given by Newton states that the rate of change of momentum, right? So when we say momentum, we are saying about linear momentum, right? So linear momentum of an object is directly proportional to the applied external force, and this change takes place always in the direction of the applied force. Okay, right? So this force applied, okay, what it creates change in momentum, change in momentum. Okay, so this force applied is proportional to change in momentum divided by time taken for that change. Is that clear? Time taken for that change. It means that when a bigger force is applied on a body, its momentum changes at a faster rate and take less time, and vice versa. If less force is applied, then its momentum will change in more time. Are you getting that? Okay. So this change in the momentum, because the force is applied, there will be change in the momentum, right? Okay. And this change will take some time, right? So how fast this momentum will change, right? This depends upon the force applied. Are you getting my point? Right? So what is momentum? Momentum is mass into velocity, right? So when we apply some force, what will happen? Its velocity will change, right? There will be some initial velocity, suppose, for the body, it is moving, right? Now it is attaining some other velocity, the final velocity, right? So there is a change in the momentum. पहले किसी और velocity से move कर रहा था और अब किसी और velocity से move कर रहा है. Getting that? Right? And this change happens in some time. इस change को होने में कुछ time लगेगा. Right? तो ये जो पूरा ratio है, this ratio depends upon the force applied. Right? So how fast its velocity get changed, how fast its momentum get changed, it depends upon how much force, external force is applied. Okay, and this change is always takes place in the direction of the applied force. Okay, are you getting my point? Yes or no? So let's see what is the mathematical formation of second law of motion. Okay, means now we will find out how we are getting that second law, F is equal to ma. Okay, so we are just doing the derivation of it. Now suppose if a body of mass m, okay, moving at initial velocity, u, is the initial velocity, okay, or we can write down these things directly, like m is the mass. M is the mass of the body. Okay. U is the initial velocity of the body. A is the acceleration. Okay. And this acceleration is for time t. T is time. Okay. And since it is accelerating, its in final velocity will be different. So suppose v is the final velocity. Right? So what is going on here? There is a body of mass m moving at initial velocity u, accelerates uniformly with an acceleration a for time t, so that the final velocity changes to v. Then what will be the initial momentum? What will be the initial momentum? Initial momentum means P1, suppose. P1 means m into v is the momentum, right? But here the v should be the initial velocity. That will be the initial momentum, right? So P1 is equal to m into u. Getting that? M into u. U is the initial velocity. Similarly, final momentum will be final momentum, that is P2 is m into v. So mu is the initial momentum, mv is the final momentum. Getting that? And what will be the change in momentum now? Change in momentum, because body is moving, body is accelerating with some uniform acceleration. So there will be the change in the velocity and there will be the change in the momentum also, right? So change in momentum will be P2 minus P1. Getting that? Means mv minus mu or mv minus u. So what will be the change in momentum? P2 minus P1. Sometimes we also call it as delta P. Means change in momentum. Getting that? This is the change in momentum. Now, according to the second law of motion, please understand, you can note it down later. According to the second law of motion, what second law of motion says? Look at here. Second law of motion says that change in momentum in time is force. Getting that? Yes or no? Change in momentum in some particular time is directly proportional to the force applied. Right? So we will use this here. So according to the second law of motion, force F is directly proportional to change in momentum upon time in particular time interval, right? So F will be proportional to P2 minus P1, right? This is the change in the momentum upon T. Getting that? That means F is directly proportional to, now what is P2 minus P1? We have calculated here mv minus u, isn't it? So write it down, mv minus u upon T. Okay. So now F is directly proportional to, now can you tell me what is v minus u upon T? What is v minus u upon T? Change in velocity over time. What is it?
Acceleration.
This is acceleration, yes. Right? So v minus u upon t is our acceleration, right? So can we write it down as F is directly proportional to m into a, right? Now, whenever we remove the sign of proportionality, we have to always multiply with the constant, which is the constant of proportionality. Suppose it is k, kma, right? Okay, where k is the constant of proportionality. Okay, right? So K is taken as 1. K is 1. Okay. If F is 1 unit force, 1 unit, mass is 1 kg, and acceleration is 1 meter per second square, then K will be equal to 1, right? So we have assumed that here K is 1. So therefore, F is equal to MA. And this is your another form of second law of motion. F is equal to MA, right? Now what is the SI unit? SI unit of force is Newton, denoted by capital N, right? And 1 Newton force is equal to 1 kg meter per second square. Okay, so 1 Newton is equal to 1 kg meter per second square. Is that clear? Okay, so there is a smaller unit also, that is 1 dyne, dyne, dyne. Okay, and this is 1 upon 10 to the power 5 Newton. Or you can also write it as 10 to the power minus 5 Newton. Right, so this is the smaller unit of force, 1 dyne. Okay, so if the applied force is 0, then acceleration will also be 0, and body remains in the state of rest or the state of motion, uniform motion. Getting that? So F is equal to ma means if force applied is 0, suppose, then acceleration will also be 0. Mass cannot be 0, right? Mass is something which cannot change, right? It cannot be 0 for an object. Okay, so if force is 0, then acceleration will be 0. That means body is either at rest, or if it is moving, then it is keep on moving with the uniform motion, with the uniform, in the uniform motion. Is that clear? How we can define 1 Newton force? 1 Newton. 1 Newton force is that much force which produces an acceleration of 1 meter per second square in a body of mass 1 kg. Right? So how you will define 1 Newton force? That it is that force which produces an acceleration of 1 meter per second square of a body of mass 1 kg. Then we say the force is 1 Newton. Is that clear? Okay. So 1 Newton is equal to 1 kg into 1 meter per. Is this clear? So what we learn from this Newton's second law? What we have learned from this Newton's second law? Very first thing, that no force is required to move a body uniformly along a straight line, right? So if body is moving uniformly, means with the constant velocity along a straight line, then no force is required. Okay, it will keep on moving with the same velocity, right? Okay. Second thing which we have learned, that accelerated motion, if the motion is accelerated, means now velocity is not uniform, right? It is accelerated motion. Then it is always due to some external force acting on the body, right? तो अगर कोई मोशन एक्सिलरेटेड मोशन है, इसका मतलब उसके ऊपर कोई एक्सटर्नल फोर्स लग रहा है, तभी उसमें वो एक्सिलरेशन आया है. ठीक है? अदरवाइज अकॉर्डिंग टू द फर्स्ट लॉ ऑफ मोशन, वो जिस वेलोसिटी से मूव कर रहा है, यूनिफॉर्म वेलोसिटी से, उसी यूनिफॉर्म वेलोसिटी से वो मूव करता रहेगा, राइट? अगर वो एक्सिलरेट हो रहा है, अगर उसकी वेलोसिटी चेंज हो रही है, इसका मतलब कोई एक्सटर्नल फोर्स हम उस पर अप्लाई कर रहे हैं. दैट मीन्स देयर इज सम एक्सटर्नल फोर्स व्हिच इज अप्लाइड. Okay, and this force, the magnitude of this force acting on the body is always equal to the product of the mass of the body and the acceleration of the body. अब ये जो external force है वो किसके equal है? M into A के, mass of the body into acceleration produced in the body, right? That will be the magnitude of the force. Why we are saying magnitude? Because the force can be in any direction, right? Okay, right? If you're applying a force in opposite direction of the motion, that will stop the body which is moving. Okay, right? And if you're applying the force in the same direction it is already moving, then it will accelerate it, right? If you are applying the force in the opposite direction, then it will deaccelerate the body, and that is retardation, and it comes to rest after some time. Is that clear? So frictional force is also a force, right? It is also external force which is always applied, right? Whenever there are two surfaces, comes in the contact. And there's a reason when your car is moving with some velocity, right? You need to accelerate it, right? It's not like that. It does not follow that Newton first law. It is actually following, but there is an external force that is a frictional force which always opposes the motion, right? इसीलिए हमें उसमें फ्यूल यूज करना पड़ता है, राइट? अदरवाइज अकॉर्डिंग टू द फर्स्ट लॉ ऑफ मोशन, एक बार आपने स्टार्ट कर दी फिर तो वो चलती ही चली जानी चाहिए, है ना? अकॉर्डिंग टू द फर्स्ट लॉ ऑफ मोशन, right? But there is a force which is always acting whenever there are two surfaces in contact, and that is the frictional force which always opposes the motion, which always applied in the direction opposite to the direction of the motion. Okay, so that is friction which actually helps us in walking. Okay, so this is an unnecessary evil, right? It is something which is very, very important, right? Okay, is that clear?